Welcome. My name is Nicole Lamoureux. I'm your facilitator today with ERLC. Our session is an introduction to the scientific methods in Alberta's new science curriculum for grades 1 to 6. The agenda for today is, first of all, we're going to look at a background builder for ourselves of what science is as a discipline. Many of us are elementary generalists who may or may not have a background in science, and it's always a good refresher as this provides a context for us to unpack the science methods as an investigative process. As well, we're going to look at the overview of the grades from 1 to 6 to see how these investigative methods build over time and zero in on certain aspects of the investigation cycle. It's important to remember that we have our students with us in 1 year of their educational journey from kindergarten to grade 12. And this is a shift or change in the science curriculum. If you've taken sessions with Chris and Ted, you'll notice they talk about how the knowledge is building over time. And that's exactly the same way that it happens in the scientific methods. Science is much more than a subject in school or that you study in post-secondary or research later on in life. It's something that confronts us as citizens on a day-to-day basis. We came out of a pandemic recently where, do I mask? Do I not mask? Vaccination or not? Science seems to be changing its mind constantly. Some of those comments might reflect a lack of understanding on the process of science and how knowledge is built. Also, our students are going to be faced with these continuing issues, such as global warming, where they're going to have to make informed decisions. So scientific literacy and the development of that with our students is very critical. Some of the key learnings that I'd like you to walk away with today is an understanding that science uses methods of investigations to build knowledge and understanding of the natural world. Setting that stage or knowing that each grade level learning outcome and cusps in the scientific methods unwraps a deeper layer and focus within the investigation cycle, and that our students will build on aspects of that investigation cycle from grade to grade. To begin, we're going to look at science as a discipline. What is science and what's the purpose of doing science? Well, science is the study of the natural world to investigate phenomena. Phenomena are observable events or situations that happen and then that generate questions and an attempt to explain the reasoning behind it. Why does it happen? What's the cause? How does this work? For example, we have a virus. It's causing people to be really sick and hospitalized and more serious than a flu. What virus is this? How does it work? What can we do to solve it? So that's the nature of science, but we also want our students to be scientifically literate. And it's always important to take a moment to go back to the curriculum subject introduction. I know many of us want to zero in on our grade level and sort of unpack that and really know what we need to teach. But taking a step back and looking at those curriculum subject introductions really provides you with a background knowledge about what is the expectation in this curriculum and why it's designed the way it is. And one of the areas they talk about in scientific literacy is scientifically literate citizens are equipped to evaluate sources of information encountered in daily life. So that's something that we want, again, in that educational journey for our students to grade 12, and that we need to start building because it doesn't just happen in secondary or high school. If we're going to help develop scientific literacy with our students, it's important to unpack what that means. PISA, the Program for International Student Assessment, defines scientific literacy as being competent in 3 areas of science. The first is having content knowledge or conceptual knowledge of the understanding of science ideas in the various disciplines in science. So in our organizing ideas, we have our physical sciences with matter and energy, and we have earth and space sciences, as well as the biological sciences with living systems. I'm sure you've worked or have been unpacking some of the concepts within those organizing ideas at your grade level. But it's important to remember that science is much more than a body of knowledge. It's a way of thinking, and that the knowledge in science is built through investigations. So that comes next, and that's where scientific methods come in, is the procedural knowledge. So having our students do investigations in order to build knowledge. and go through that inquiry cycle, which I'm sure many of us are familiar with. However, in this particular curriculum, what's coming out as well is something called epistemic knowledge, and that's just a fancy word for knowing how knowledge is built. So, for example, our students are going to be knowing that how science collects data, not just by doing it, but also by knowing about that, and also how theories are developed or generated, how hypotheses are made and used. I think this quote from Carl Sagan about science as a way of thinking much more than it is a body of knowledge encapsulates the scientific literacy. Knowledge is still important. Students are going to need to be exposed to knowledge, but the idea that knowledge can be built through an investigation can be done with our students. Many of us are familiar with our 1996 curriculum, and just a quick reminder that we did have science inquiry skills in that area, and you would have seen it in the front of each grade level. And the expectation in that particular curriculum was that the skills would be embedded within each topic, and they would be taught and assessed as well. There was skills with problem solving through technology, which was the engineering aspects. Our science methods looks different, and there's some different focuses at each grade level as we go through, but the idea of science inquiry is still predominant in the scientific methods. Before we unpack the scientific methods, I'm just going to have a couple of slides where I talk about how would we go about teaching, or what does this mean in our classroom. So there's been a significant amount of research since 1996 on science education, and one of the areas was looking at hands-on investigations versus text, or using both. And in remembering that we're developing that scientific literacy, it's really important that students use investigations to build knowledge, because that is what happens in science. So what came out of the research is that classrooms who use both investigations and text, specifically with reading, significantly outperformed those that used either just straight hands-on investigations or straight text. Traditionally, in our science classrooms, oftentimes the explanation comes first. That could be through a video, or providing vocabulary before they learn about an idea, or talking about it with our students, or reading in the textbook. And then what would happen is we would give students an opportunity to do some hands-on investigations and kind of have that experience in science and talk about it after. Well, the research in science education is looking at flipping that for a reason. And that reason is that our students need to experience how science knowledge is built through an investigation. If we're giving the information first, that's one reason. They're not going through that authentic science investigation. Second reason is students, if they hear the terminology, and some of this sounds very different to them, if you want to think about it like learning a foreign language, if you hear terminologies but you can't attach it to something, it's not going to make sense to you. So when students do an investigation, it's a way of thinking. They're trying to make meaning. So what does this look like in our classrooms? Explore before explain in the classroom looks like the student is using a phenomena to spark that curiosity and find answers to it through an authentic investigation. Through that, students are excited, they're making meaning. They may not have the scientific vocabulary yet, but when they're introduced to that vocabulary, it's going to make a lot more sense because they have something to anchor on which they can make a connection to. Then after students go through that, or as they're going through it, you can do just-in-time teaching to bring in the vocabulary, bring in the concepts through, enhance it through text and video. Now that we've looked at the different approaches and instruction and what science is, I think it's time now to unpack the scientific methods in our classroom at each grade level. We're not going to go in depth. We're going to provide an overview to see how it develops and how each grade works through the cycle of investigations. When we hear scientific methods, I'm sure the traditional classical scientific method approach comes to mind. That's what I think most of us are familiar with. Observation, question, hypothesis, planning materials. And in fact, sometimes we went off our curriculum expectations and just taught this process. But I think we need to keep in mind that's only one approach or method of investigating phenomena, and that this classical scientific method approach of using controlled experiments starts in grade 5. So we're going to just look a little bit about investigations and the cycle of that before getting into each grade level. So there's many different disciplines in science, and I put up a picture of Jane Goodall with her gorillas, and that she's in the field. Well, it's hard to control provide controlled variables or control your environment in that situation. So descriptive investigations are more appropriate in that field. And comparative investigations, where you would look at changes over time, or like ecosystems, or comparing temperatures over time in different seasons. And then, of course, we know about, in high school, we learned a lot about experimental investigations, and it's still important. There's no hierarchy. It's just that certain aspects or certain fields and disciplines lend themselves better to different types of investigations in science. So experimental investigations have that one controlled thing that you're testing for. What's going to keep the maggots out and away from spoiling the meat? You can see here, the only thing that changes is the seal. So those are the sort of differences or the purposes of the investigation, and that again, that knowledge about knowing science, the students have to know that the purpose of investigation drives the methods in which you approach that you go about doing it. To sum up, investigations is the umbrella, and underneath are the different types of investigations. But if we're looking at experimental investigations, both investigations have a purpose. They have a question that drives the inquiry of what the students want to find, some kind of phenomena they're observing, whether it be facts, data, situations. The investigations, not all of them follow a complete scientific method, and a hypothesis is not necessary. However, in an experimental investigation where we are developing a fair test, we want only one thing to change to see the impact of that one thing, then the classic scientific method is applicable in that situation. This leads us now to looking at the scientific methods. I pulled out the organizing idea that goes across the grade levels. Investigation of the physical world is enhanced through the use of scientific methods that attempt to remove human biases and increase objectivity. You may be observing the chimpanzees or the gorillas in the field, but you still have to remove some biases, and you still have to have some objectivity in your investigations. So the question comes up is, how do I go about starting to teach this? Am I expected to teach it as a separate unit or embed it into the subject areas? I think, again, going to the subject introduction, especially the specific area of scientific methods, I pulled this out. It says students will have opportunities to integrate these skills into all other areas of the science curriculum. So whether it's your professional discretion, if you have time to do a unit at the beginning, you can, but you're still going to have to continually embed this throughout in all the other organizing ideas, or you can embed into the organizing ideas and do something I call a just-in-time teaching, where when they're doing the investigation, I always taught like this. I would say scientists always make observations and look closely, and they ask questions. So or scientists will plan an investigation, and I always kind of use that terminology to help teach the students. And sometimes I'll ask my students after I've taught them a while, I'd say, well, why are we asking questions, or why are we doing this? And then they can give you the answers back as well. We're going to look at the scientific methods at each grade level and sort of see what the focus is. I want you to think of the inquiry investigation as an inquiry cycle. And so I'm using the analogy of an onion, that each grade level sort of peels a certain layer of a certain aspect of the investigation. They'll continue doing the investigation, but they'll focus in and learn more pieces as they build through the grade levels. In elementary, the science investigative inquiry cycle has been laid out in grade 2 completely. We'll look at grade 1, which is a simplified, smaller version of this, but in terms of going through most of the grade levels is asking questions, making predictions, planning the investigation, observing and recording data, analyzing data, reaching conclusions, discussing observations and conclusions. So what you'll see at each grade level is going through this, but unpacking certain pieces of what does it mean to observe and record data or analyze data. And the expectations grow as they continue through the grades. As a kindergarten teacher, you realize there are no scientific methods in the curriculum. Many kindergarten classrooms are half-time. However, if you look at the computer science learning outcome for kindergarten, which states that children interpret instructions in various environments, we can still do some investigations, simplified versions of investigations, which lends to following sequence of instructions. So there's procedures in an investigation. Those are steps that students can work through some of this computational thinking on instructions embedded in their investigations in science. And we're going to start with grade 1, but I just want to point out that grade 1 is the inquiry cycle on a smaller scale. So we know, and this is just a reminder, that the organizing idea I've already looked at in every grade level, just like in all the architecture is the same in every subject area and every organizing idea, that we will be having the guiding questions, which you could change into student-friendly language as well, and the learning outcome is the expectation for the full year. All the cusps under that particular learning outcome in the scientific methods lead towards we must teach all of the cusps. We don't need to assess every single cusp, but the assessment and the summative piece comes out in the learning outcome. We do want to also do some formative assessment and assessing along the way with regards to the cusps. So this is the same architecture that is laid out for all of the curriculum. So we're going to begin with grade 1, and grade 1 starts with the very basic foundation. What is investigation? They're going to engage. The expectation in the learning outcome is engaging in and describing an investigation. So I like to pull out a bit of scientific terminology because just to refresh ourselves, but most of it will come from the curriculum, but I'm going to highlight certain things. For example, prediction. A lot of times, it's very difficult to come up with a student-friendly term, so I've often heard smart guess. But when you're a student, what does a smart guess mean? So what I really like is the curriculum has defined it in that students need to know that a prediction is a likely answer based on their current understanding or knowledge. Also, they look at a conclusion, which is an answer to the question in the inquiry cycle that is gathered based on gathered data. So if you look at the cusps for grade 1, they learn that, they know that investigations aren't carried out by a number of people. It's not just scientists, teachers do it, police and doctors have investigations, but that they're sparked with curiosity. And they outline the steps to the inquiry cycle for grade 1 as the foundation. And here we've talked already about prediction and conclusion. So in order to do a prediction, they need to know what it is. So that leads to the skill of the answer to a question. They have to ask a question which sparks curiosity, and then they describe the steps of an investigation. And this can be done multiple times in every investigation in all the organizing ideas, and learn, or you can start with focusing on predictions first and making good predictions and assessing those. They can still learn the other pieces, but continually to refine and build those skills throughout the year. So as I mentioned, we don't just do one investigation and go through the cycle. It's a multiple cycle. But for grade 1, it's a simplified version where they focus on asking the question, making the predictions. So I put the skills on here that they predict answers to a question based on their current understanding, which would be a criteria. They gather data that could be done together, and they form conclusions. And so the expectation is to describe the steps involved in this. And asking good questions, phenomena is a great way to spark that. Something that's relates to student lives. So that would be the highlight for grade 1. Now, as we build towards grade 2, we look at the guiding question of what methods and processes can be used in a scientific investigation. So students examine investigation and explain its influence by purpose. And that's really becoming important, again, that knowledge about how science knowledge is built. We go through an investigation for a reason. And if we look at some of the terminology, procedures are those steps, the data, the information collected using specific processes. So if we look at the cusp here, the foundation for the investigation and for grades now starts in grade 2 and will carry through, as we'll see, up until grade 5, and then in grade 5 and 6 it's added to and expanded upon. So students are carrying investigations for a purpose. So here we have the list of what is the procedures involved in an investigation. So they're going to explore the various purposes, which is laid out in your knowledge. Now we know, okay, these are the purposes in the curriculum that we are going to connect to. That we're going to answer a question, we're building our knowledge, we're satisfying curiosity and problem solving. So they're going to describe these procedures and develop questions for the purpose. So that'll be something that we have to teach our students, that we're going to specifically ask questions based on the purpose of what we're trying to investigate. So if we look, the next cusps are the investigations involve data. So they're going to really start honing in on that area, and observations should be similar if their investigation is repeated. Okay, so what I'm going to do is I'm going to lay out the investigation cycle, and we're going to see this, and what they're going to still make predictions from grade 1. That's a prior knowledge they're going to bring through when they do their predictions, because that is the good cycle of an investigation. But now they're going to develop questions on their own for the purpose of an investigation. They're going to collaborate together to collect data on a single chart. And then when they start to analyze a little bit in grade 2, they're going to determine if the observations relate to the purpose or not, or they're extraneous data that we don't really need. So that's, they're going to reach their conclusions because that's what they were doing in grade 1. So that still gets pulled through, but we sort of unpack that layer a little deeper in grade 2. So in grade 3, now that we've got the foundation of the steps laid out in grade 2, grade 3 starts to build on that. Well, how is knowledge built in science? And it comes back to that very piece of knowing how knowledge is built starts in grade 3. Students relate investigation to building knowledge. So some of the terms, just to be clear for ourselves, some of them are clarified in the curriculum, some of them I'm just adding. Accuracy is the correctness of measurements that are exact. Objectivity is started to be bringing out in the cusps, not influenced by your personal feelings or your personal biases, that what you think should be happening. So collection of data becomes very important in the cusps in grade 3, and they will collect data to improve their accuracy, compare sources, and the sources are laid out. So for grade 3, the expectation to know the sources are investigations, texts, websites, etc. that you can read through. So you are kind of have the parameters established for you for what grade 3 level should know about the different sources of data in order to collect it. And as well as data can be considered accurate. So how do we know when it's accurate? And that's something that's laid out. So when they look at textbooks or peer-reviewed journals, that's interesting. Elders are knowledge keepers, and as well as analyzing data. So if we look at the cycle, which it is, the investigative inquiry cycle, they're still developing new questions to further investigation. That's a skill brought through from grade 2, making predictions. They're going to work through their planning and investigation, but they're going to collect data and improve their accuracy when they collect it. So that is a skill that we'll work on with them in grade 3. Then they'll start working a little bit deeper in analyzing. Then we're going to unpack more layers in analyzing data. They're going to make connections to previous knowledge. They're going to compare accuracy with each other. Okay, I measured the length. His measurement's different. Why is that? It should be the same. Let's check and see how we're measuring. We're going to notice changes and discuss and collaborate together as we look at our data. And now we're looking at reaching conclusions and discussing observations and conclusions, so that communication piece. So then they'll reflect on how data is building their knowledge that contributes to the knowledge building in science. So that really is starting to count foundational piece of that knowing how the inquiry cycle or the investigations build knowledge in science. In grade 4, we're going to continue with the investigation cycle, but students now are going to zero in more on the depth of learning about investigating evidence and reflecting on its role in science. As we have done in the other grades, we'll just highlight some of the terminology. So qualitative data or evidence is using descriptive words to describe the data, and then quantitative data is amount using numbers. A lot of times that's measurements, speed, time, length, distance. And evidence, which is the students are being introduced to now, is a body of facts and information collected from data. So the data is just this is a fact, this is what we see, this is the observation. Now we're going to pull that as evidence, and you can include other sources of articles and videos as well. Reliability is something that students will be introduced to, and that's the consistency of data collected. And validity is how accurately the data and evidence reflect what is supposed to be described and measured. So when we look and examine the cusps, you see collection of evidence is the first one. And here, students need to understand that a collection of evidence provides a way of expanding our knowledge on previous knowledge that's being built. So again, this pulls through from grade 3 where they learn about building a body of knowledge, how investigations do that. We're going to examine the skills as we do in the inquiry cycle, but what I want to point out here is now students need to know about and work with the relevancy of data. Is it addresses the question or not? Some data is, sometimes students want to pull it all in, but let's sort through this. And all relevant data must be considered and brought forward. When we look at the second cusp, we're going to be drawing conclusions down the investigation cycle based on reliable and valid evidence. So students start looking at that reliability and its validity as we talked about in the terminology. Again, I'm going to bring through the cusp, the skills in the inquiry cycle, just to see where that's being pulled out and unfolded in a deeper layer for grade 4. So again, the students are going to go through the inquiry cycle that they've already been building and understanding with asking questions, making predictions. They're going to go a little bit unpacking deeper with deciding whether to collect descriptive or measure data during an investigation. And they can reevaluate that when they're through their observations, but they're going to collect valid data using tools or technology. And then when they're analyzing, they're going to collaborate to evaluate, focusing on the reliability and validity of data. And they're going to interpret the data using the standard international units. Now we know the standard international units are great for Canada because we are in a metric system. And now into drawing conclusions or reaching conclusions, they're going to represent their data in a variety of ways, and they're going to pull from the data some reliable and valid evidence that they're going to include or integrate with other text or other forms. In grade 5, we can see a building on talking about evidence. How does evidence lead to understanding? So they're going to investigate how evidence is gathered and explain its importance in ethics and science. So that's connecting back to the reliability, the validity of gathering evidence and different forms of evidence as well. Okay, a little bit of terminology here in grade 5 that we're going to be building on, and we know about phenomena. We've talked about phenomena quite a bit, and this is where in grade 5 the term phenomena is formally introduced. So you're going to see different spellings. I'm just going to point this out. ON is singular, and the A that we see in the curriculum is in plural, multiple. And those, again, are facts or events that can be observed. So again, we're looking at reliability, which is consistently good quality, valid, how correct the results are. A variable, which a lot of us know, but just to refresh our memories, a factor or trait of amount that can vary. Again, coming back, now our students are being introduced to the experimental investigations. So they're going to be introduced, and they need to know how to use this term of manipulated or independent variable, which is the one thing that will change in the experiment when all else stays the same. Responding or dependent variable is what researchers predict will change or be the result of happening from introducing the independent variable. And so this is a controlled experiment. You want to ensure a fair test. It's not the full scientific method yet because they're not introduced to a hypothesis quite yet, but they're building that background knowledge to carry them through into grade 6. As I mentioned, the term phenomena is formally introduced in grade 5, but also where we look at here is that some phenomena cannot be directly observed using the human senses. So we've probably up to this point been having our students make observations using their senses. So for example, in matter, students in grade 5 are introduced to the particle model of matter. And that's something that the atoms and whatnot, they cannot see. So this is where they're going to talk about, well, how do we observe this phenomena? And that's where technology supports in that area for things that are too small to see or too big. So kind of that scale of phenomena that might be unobservable for our students or for scientists. Bias is brought in. Again, we're talking about ethics. So we want to ensure a fair test. We need to sort of be aware of or identify biases that could influence an investigation. It's more reliable and valid when we limit the bias or personal feelings that could influence an investigation. Now, as I mentioned, they're introduced to the experimental investigations through controlled experiment that they make conclusions about the cause and effect relationship between variables. We hear cause and effect in science, and sometimes that gets misinterpreted, something similar to language arts. It's a broader concept, and in science, the cause effect, of course, is the connection between the effect being the response and the cause being the independent variable in most cases, or what's called, the relationship between the two are the science ideas, is actually the relationship between that cause and effect relationship. So they should be, they learn about manipulated independent variables and responding and controlled variables, and what a controlled experiment is. So they're going to go through, and on my chart as well, they're going to be representing and communicating evidence, because that is an important aspect of the process of investigation, is to share your findings. And so we're going to look here. Continuing on, looking at our inquiry cycle and where those layers get pulled in deeper for each grade level. Grade 5 starts again with the phenomena, as we mentioned, where things that can't be observed, we need to use technology to assist with. Of course, they're going to ask questions based on that and make predictions, but now they're going to plan and conduct controlled experiments. They're going to identify and use the vocabulary of these variables correctly. That is an expectation. They're also going to continue identifying potential biases that could influence the investigation or the data, which they've learned in grade 4. So if we look here at observing and recording data at this part of the inquiry cycle, they're going to apply the vocabulary, they're going to identify those biases as well, continue that through. They can try before they plan to minimize it, and then again, as they observe, they want to continue to ensure that that's being minimized. They're going to evaluate effects of manipulated variables on the responding variables. So that's the analyzing of that data and looking a little bit at the cause and effect relationship that we talked about. When they reach their conclusions, they're going to really look at those relationships, which is usually the science ideas. And then we're going to start looking at discussing observations and conclusions, which is what scientists do. So they're going to discuss diverse representations of data and communicating their evidence, compare clarity and accuracy of evidence communicated by diverse representations of the data, and discuss potential impacts if data is not communicated clearly and accurately. For example, I think of students not, when their graphs, when they develop their graphs and they're incorrect or they haven't used the line properly, what would be the impact on that? Are they representing the data accurately? What would happen if someone read that or looked at that? So those are sort of the things that will be looked at deeper in grade 5 to prepare them for grade 6. Now in grade 6, students are continuing to build on their knowledge about experimental investigations as they learn about the purpose of a scientific explanation. And they can still do regular investigations, but we want to develop the skills in an experimental investigation. So they're going to investigate and describe the role of explanation in science. Again, pulling out some of the terminology, now grade 6s are formally introduced to a hypothesis, which is defined in our curriculum as the proposed scientific explanation developed prior to conducting an investigation and based on their prior knowledge. Similar to a prediction, but a little bit different because it's a causal explanation of thinking what might be causing this. Scientific explanations in general make sense of phenomena based on the investigation. So a hypothesis has an idea that they're going to test out, and then the explanation at the end when they share out their ideas shares out based on evidence, as we'll see in the cusps. So as I mentioned, grade 6s are formally introduced to a hypothesis. The criteria and the parameters for grade 6s, what they need to know, is in their knowledge statement in order for them to develop and test the hypothesis based on scientific explanation at their grade level. And so they know that this is are used to in science to answer scientific questions that are posed that they've been working on all along in the various grade levels. As we go through the inquiry cycle and they have tested and they're drawing their conclusions, they need to share it out. And that's through a scientific investigation. And that's the purpose is used, and evidence is used to support or contradict your hypothesis. And the objectivity and high level of accuracy produce a trustworthiness. So your explanation should be solid if it's based on evidence to support it. And so they will have to do scientific explanations after they go through their investigations. And we will look at in the skills a little bit further where this is in the inquiry cycle. The expectation of that for students is to know what a scientific explanation is and develop one. And now we see that multiple methods of communicating scientific explanations are expanded on in this particular cusp. So scientific explanations can incorporate a variety of texts. So they can use their graphs, make models, diagrams in order to explain. It can be written, it can be verbal. As well, we bring in First Nation, Métis, and Inuit perspectives and how they would explain phenomena. And so the skills we'll look at in the inquiry cycle of where this is what students will use to further enhance and develop multiple methods of communicating scientific explanations at their grade level. As students are exposed to different types of scientific methods, they're going to discuss the processes that can be used to validate the evidence and explanations. So they will look at and know that further investigation involves the continual collection of evidence, that science is self-correcting, and that's part of knowing how science knowledge is built, and this is the aspect of that. They're going to identify different explanations that have been refined or changed, and they'll have examples here. But I really like this one at the bottom that says one conflicting study is not enough to cause a scientific explanation to be refined, so that they need multiple sources to confirm that way of thinking needs to be changed. So in grade 6, if we look at this inquiry cycle, they're going to bring through some of the skills that they developed in grade 5, observing the natural phenomena that is too small or too big to see that we need assistance with technology for. They're going to continue developing questions based on those phenomena observations, but now we're asking our students to generate a hypothesis. They have the background knowledge of experimental investigations with manipulated and responding variables, so now they can develop and test a hypothesis. They're going to continue to plan the investigation as they did in grade 5 and observe and record their data. Another layer that we're going to add in analyzing data and reaching conclusions will be interpreting multiple forms of text that offer explanations of the phenomena. And we're going to look at reaching conclusions, but also discussing and discussing observations and conclusions. So what goes deeper in here is they're going to share out their explanations through graphs, and the skill sort of lays that out. They're going to create scientific explanations of how the phenomena occurred. They're going to explain it and use evidence to back it up. They're going to discuss their observations and measurements and create those explanations and construct digital or non-digital explanations. So that could be They could, if they're using models, I think of technology to create models of using computational thinking can be brought in to create models. They can discuss their observations and measurements used to develop the explanation. So they should be giving that, how does that support, how does that evidence and their measurements, how does that show or answer the question? They should illustrate that a little bit further. And then again, we talked about the identifying of different phenomena that have been refined and new evidence that sort of changes and refines scientific knowledge over time. This concludes our time today in this session, and I hope that the key ideas that you walk away with is that science uses methods of investigations to build knowledge and understanding of the natural world. This is what we want our students to do. Each grade learning outcome and cusps unwrap a deeper layer and focus from the investigations, as we've been pointing out. They go through the cycle, but they'll unwrap and go deeper. They'll also know that they can build on aspects of an investigation at each grade level, and that this knowledge and skills continue through to the next grade level as they build more in their science understanding. So I just want to thank you for joining today and taking the time to learn about the new science curriculum and help your students as they learn some exciting new skills and ways and understandings about how the world works.